And we said, hey, look, we can build this factory in 9 months and we can double it and all that. They said, hey, uh, um, they said it very nicely, but they basically said, you guys are idiots because if you build a product like this, you're not going to be able to keep up with the demand.
Hi, everyone. Welcome back to another episode of Renewable Rides. Today, we are excited to be joined by Haroon Inam, CEO, and Michael Wood, Chief of Staff from DG Matrix. DG Matrix is a company making the world's most compact power router for aggregating multi-technology distributed energy generation and storage systems to maximize the value from both the development as well as optimization of these energy systems. In today's episode, we touch on the challenges with status quo power management technologies, how DG Matrix is streamlining the engineering, interconnection, and system optimization process, and how being humble and staying present are superpowers in today's dynamic world. With that, let's dig in. Haroon, Michael, thank you for joining us. Super excited to dig in with you guys today, and both with yourselves as individuals, but also on DG Matrix. As you know, we always like to start these conversations with learning a little bit more about our guests. So, Haroon, I'll start with you. What are you passionate about? What gets you fired up? What keeps you going?
Thank you very much for inviting us, Dan and Gareth, to this podcast. My passion from as long as I can remember has been kick butt products that meet and exceed needs. Right. So on weekends I go and geek out on things and just start testing them to see. And I'll geek out on anything from a cool garage door opener to the latest iPhone. But I'm a product guy.
What's the latest? What's the most recent kick butt product that you found?
Well, I would have to say the DG Matrix Power Router. Just probably because I'm so deep into it that I'm living it and breathing it every second. So if I say it, I would be diplomatically correct, and if I say it, I would be truthfully correct also.
Okay, we're going to dig in more in that. Do you have a second place winner?
You mean for my second passion or something like that?
No, another product that you love.
Oh yeah, absolutely. I love Apple products, and the Vision Pro took a beating, but I love the Vision Pro. I like it when I can sit in a coffee shop and I can stare at large screens and do the spatial computing. I mean, I think it's fantastic. What an amazing thing they came up with, and it's only going to get better. I find it very productive to watch multiple large screens when I'm sitting in constrained spaces.
That's awesome. I need to try that myself. Michael, excited to dig in with you as well. What are you passionate about?
Similar focus on technology. I went into engineering school thinking, okay, great, I'm going to get an engineering degree and go do something business finance related. And turns out I actually love technology and engineering, and even better, I love leveraging that for energy industry. And so, just everything around energy and the industry is kind of what I'm passionate about. Grew up with a family background in oil and gas, and now getting to do something in a new realm of energy. So just really focused on working with Haroon and team to scale some awesome technology. And then on the other side, to bring as many of the best and brightest people into this industry as I can.
So build on that for us, Michael. How did you go from oil and gas to renewable energy and to DG Matrix in your current role?
Great question. So on the first one, so family backgrounds in cattle ranching, oil and gas, and of course, like being and spending so much time around the ranch, a big part of that was wildlife management and sustainability. So I always grew up with that focus. And then in parallel, I was doing some various entrepreneurial things. I started my first company at age 9 selling fishing lures. And so that kind of carried with me. And then it wasn't until my freshman year at Duke that I realized how all of these things could merge together. I was by chance kind of ended up working at an energy startup in San Antonio, Texas. And it was a total light bulb moment. I can blend my family background in energy with passion for sustainability, with engineering, with entrepreneurialism. And after that, I was hooked. Founded another company in college called Energy Terminal, which started off as a media platform and then grew into us helping companies with talent acquisition and that passion of bringing the best and brightest into the energy industry. And that is actually how I met Haroon and joined very early on the DG Matrix team. And it has been a wild and exciting ride ever since.
So good. And Haroon, you've had a wild career. Do you want to give us the highlight reel of how you ended up getting here today?
Well, I think, yeah, absolutely. I am like Michael, a Duke graduate, and as I was getting ready to graduate with a bachelor's, I looked at the job market, and it was dismal. And I found a graduate program at Duke in power electronics, and people said, "Hey, if you join that program, you will always get a job." But the problem is, it's like horribly boring, and nobody ever does anything new in it. So I said, "Man, nobody will ever give me the credit, but you know what? I'll be able to find a job. So what the heck?" And I got into something that I didn't realize would become such a hot profession 20, 30, 5 years later. And I was lucky. Duke in those days had one of the top 3, 4 programs in the world, a really vaunted program. And I learned from Dr. Thomas Wilson, um, world renowned and also a super nice guy. And he taught me not only power electronics, but more importantly, how to be a solid citizen. And he taught me work ethic like I had never known. And the most valuable thing he told me was, hey, if you don't absolutely love the profession you're in, please go find something else. And so since I graduated with my master's, I don't think I've worked a single day in my life. So that's how I got into it. It's one of those things that became a very hot profession, but it was by mistake, and I used to bemoan my fate. How did I end up here? And now I am so glad looking back. As they say, you can't connect the dots forward; you can only connect them backwards.
Haroon, for our listeners that may not be aware, can you maybe describe or define for us the kind of the world of power electronics?
Yes, absolutely. So power electronics, I mean, people may understand what are electronics, like phones you hold in your hand, or a computer that you might work with are basically built on electronics hardware. Power electronics is a special field of electronics that deals with the conversion of energy from one state to another, AC to DC or DC to AC. These are basic forms of energy, or combining these forms and doing something with it. And the reason it became so much more important, it was relegated to computer power supplies and maybe building power supplies in the 80s, maybe satellite power supplies. Today, power electronics is the foundation of every single renewable energy farm. Every solar cell, a DC, is converted to AC by power electronics. Every wind turbine produces energy through the rotation, but it's converted by power electronics to something that interfaces with the grid. Every EV, every electric vehicle, uses power electronics to use battery energy to drive the wheels forward. And how exciting to be able to go from 0 to 60 in 2.1 seconds in that Porsche Taycan Turbo. I don't know why it's called Turbo. It's the EV, but still, what an exciting car. And to have power electronics do it. Your iPhone charger is power electronics. So it's your jet engines in aircraft are started by power electronics. It's become so pervasive, and unfortunately, there's not enough people in the world that have the experience base to really add, and that's what creates a shortage and a demand for folks with this talent.
Haroon, and coming back to your first response about technology being your passion and the EV, I'm in the F-150 line-in, And the fact that that can also go to 60 in just a few seconds is unbelievable to me. So I absolutely love it. So from an electronics perspective, what have you been seeing in market that led to the formation of DG Matrix? What was the pain point or problem that you were observing?
Well, what is interesting is, excellent question. I was doing power electronics for a company doing transmission power flow control, and it was super interesting. We created 200 some patent applications and new ideas and 50, 80, 100 patents, and we had multi-billion dollar pipelines. And it was exciting. However, I was one day just looking at ChargePoint, and I saw that their valuation went skyrocketing high. And then I found out it went down, and I found out some, not ChargePoint, but many others had a lot of reliability issues. And I said, boy, good God, we've been dealing with this business for a long time. Why don't we get in? And we've done aerospace design, we've done rugged design that's lasted 20 years. Why don't we get in and see if we can help with more reliable power electronics? The second thing was we began to see that grid constraints were becoming a major issue. And we thought we had this set of circuits that we could deploy to add multiple AC and DC sources. So we said, maybe we have a magical combination where the tech has just been figured out and there's a massive market coming up. We did not realize that Gen AI data centers would hit and create an even bigger market. We just didn't. We're not that smart. And then when that hit, oh my God, it just created a unbelievable demand for the product.
And what specifically, and so now like digging into DG Matrix, what specifically does the technology do, and kind of what are some of the benefits that you guys deliver to your customers?
Sure, I'll use an example that maybe homeowners can relate to. But the original idea goes back 12, 14, 15 years. And I was looking at a home energy system, wondering why people are not using more solar, more wind power, and why are they not using this to power up their houses, especially in the developing world where power is so dirty and so intermittent. A lot of people are using generators, and generators come on at night and they make a lot of noise and they have a lot of emissions. So I started thinking about how do you combine all these things together? And I started doing a lot of the math behind it. And I went through hundreds and hundreds of models, and I realized, wow, you can't do this with solar because the sun doesn't shine always. You can't do it with wind because it's not everywhere, and the wind doesn't always blow when you need to wash your clothes. And you can't do it with batteries because that would be tremendously expensive to store half a days of charge in the batteries and then to discharge them. But as I started to experiment with a combination of diesel gensets and batteries and wind power and solar in the right amounts, I said, good God, this could be the lowest capex of any project. You just have to know what to use when. And that was when the equations showed the absolute best levelized cost of energy if you knew what to use when and combined it with grid pricing, time of use pricing or peak power. And so that's how it led to, wow, we could use a multiplicity of AC and DC sources, combine them with this thing that we didn't even know it should be called multi-port solid state transformer, but we could combine it in a way in a very compact box with incredible economics and go down to 10% of how other people are trying to do it with legacy components. That's how this idea came about. It didn't come about in one day. It took several months to sort of triangulate on what would be the best market application.
So is this what some of our listeners might be familiar with that you might call a microgrid controller, or is it something more or different than that?
Excellent question. I think microgrid control, a lot of people think that this is what it is, and that's one key part of what we do. We control the entire microgrid, but we also take raw solar input, raw battery, and we do all the power electronics for all renewable energy sources in one very compact manner. If you go to our website, you'll see an animation. If you're seeing it on a PC or a Mac, you'll see an animation which shows multiple inverters and isolation transformers and switchgear being installed with solar and batteries and fuel cells. And it shows all those electronics and all that software going away. And it's all you see is this beautiful monolithic tower called a power router. And that does it all for you. And it also does the microgrid controls. So it has the best granular control of extracting energy from all those renewable sources and simultaneously delivering to the building or to EV charging, let's say.
So if I'm a business owner and I want to deploy an on-site system and it's multi-technology, why would I use DG Matrix? What value does it create for me? What benefits does it generate? Is it cheaper? Is it smarter? Is it more reliable? Can you just describe what the benefit to me as a owner would be?
Yeah, Gareth, excellent question. I think I will start off with this. If our fundamental belief is that if the economics are not there, without government subsidies, you don't have a business. You're just going to survive temporarily while the subsidies are there. So when we looked meticulously at inverters and power electronics coming from Asian sources without tariffs, we said, you know what? That's the number we have to match or beat. And then we have to look at installation cost and all the engineering and procurement and commissioning you have to do. So when you look at that, we're apples to apples, we're half the cost.
Oh, wow.
Because
That's
it's
amazing.
so much cheaper to install this. It's already pre-engineered. It's one product you order. So those numbers are unbelievable. Now, when you add in solar and batteries and other things that'll cost the same, then the savings are diluted because you're adding a significant number. Then the savings are only 24 to 40%, but still significant.
Sure.
So it's a lower capex. It's far easier to install. It takes up such a small space compared to legacy. And bottom line, it's going to cost you less. It's going to make you more money.
Yeah, love that. And does it shorten the time to deployment? And is it any simpler does it make any of the interconnection or the system architecture better?
No, sorry. Yeah, that is an excellent question. Excellent question. See, if you just are doing solar and you buy solar inverters, you're going to need the grid to supply the solar power back to the grid.
That's right.
And as soon as you say, I'm going to put a solar plant and I'm going to supply it back to the grid and I need a PPA, the grid guys are going to do a study. And there's way too much solar. That study with the queues for those studies, interconnection queues at all sorts of levels, might add a couple of years to getting a permit, may add X amount of time. Same thing with batteries. Our system does this all behind the meter without exporting a single watt of solar to the grid in phase one. So we take out that longer permitting for PPAs and for solar going back to the grid or in front of the meter. And by doing this behind the meter, we guarantee to the owners and to the grid that until the grid gives us permission, we're going to keep all renewable energy behind the meter and only use it to offset loads and provide more power to loads like fleet electrification or building electrification or modular data centers or big ones when they're ganged up. And that's the real value why we can do it a lot faster. It also happens that the levelized cost of energy of marginal improvements exactly where they're needed are far cheaper than upgrading massive feeders and massive substations to deliver power just to one location.
Nice. I'd say, first of all, we're in complete alignment that projects have to make economic sense. Otherwise, they just don't get done. We haven't seen a single project being done for any other reason apart from it has to move profitability positively or reduce costs, and it has to stand on its own merit with or without incentives. So we love that. And I think being able to short circuit that interconnection piece is absolutely huge, because this is one of the biggest challenges in the market is everyone wants to deploy these systems, but they just don't want to sit there churning on it for a year waiting for an interconnection permit or having to fight with the utility over it. So I think hugely important. It almost sounds like, too good to be true. Are there any catches to it, or is it that good?
A lot of people have said that when we first started showing slides, they said, "Hey, nice slide. We don't believe you." And
Yeah.
I remember we were standing at a major trade show in Las Vegas, and one guy was very, very outspoken on how we didn't know what we were talking about and nobody could do it. And so my message to him today is, thank you for inspiring us to do even better, right, than we could have done. Because when somebody says no to us, it just energizes us, especially when we know that if we pass hurdle ABC, we'll get there. But today, we've been demonstrating for months this combination of multiple sources and the same footprint that we are now rolling out in pilots in the next week or 2 weeks. And we're installing these pilots in multiple locations in the United States. And we've been showing how you can fail any source. You can remove solar, and within a fraction of a second, thousandths of a second, the unit picks up the power from batteries or other sources. You cannot see the disturbance on the critical power ports. So it's absolutely real. We back that up. We back up our pricing, and we just have to prove the field reliability in order to start shipping in appreciable volume.
So that's incredible, and sounds like there's more applications to dig into. You started touching a bit on kind of the UPS uninterruptible power system side of things, but I wanted to dig in, Michael. I know you've been doing quite a bit of customer site visits and kind of biz dev type work. What are some of the kind of key market segments that you've been either going after or that have started to really take a keen interest on this? And then maybe you can talk through both like the industries, but then kind of where are they reaching for the most? Is it purely the economics? Is it the UPS side of things? What is it that's getting them most excited?
Yeah, absolutely. I think I'll answer those questions in reverse order. The priorities that we're seeing in the market are speed to power, cost of power, and scale. And that last scale piece is how much can I scale up my system at this site, but also the exact same problem that y'all are solving from a different angle of I've got 1,000 sites across the US. How am I going to go and tackle this massive problem without designing each site from scratch, without going through these very, very complex and expensive processes to figure out which sites I'm going to go and deploy at? One is broadly electrification. That's fleet EV charging, that's gas stations, that's any commercial or industrial site. Think supermarkets and gas stations and retail stores, big box stores, any place where there's an appreciable energy load. And then the second is data centers. And we've seen absolutely explosive demand in that market with all the hyperscalers, with AI power demands, but really across all of these different applications that we're looking at, those core priorities are the same. And something that excites us a lot, that excites our customers a lot, our investors a lot, is that DG Matrix is deploying the exact same solutions into all of these different markets. It's the same technology building blocks. It's the same configurations. It's all of the same core engine that is powering our ability to go and tackle these problems.
And does that have to scale with the size of the system, or is it the same block regardless of the number of technologies and the size?
Same core blocks. So we use 200 kilowatt and 400 kilowatt building blocks, and then we basically stack those up to be able to achieve higher power configurations.
Nice.
So let's say a big super center needs 2 megawatts of power. We stack up 5 400 kilowatt units. And while we're focused primarily in that few hundred kilowatts to a few megawatt space that is broadly CNI, we're also tackling projects that are 50 megawatts and larger. Everything is modular. Even a gigawatt data center is just built up of modular power conversion systems, modular racks, just exactly like that. It's how DG Matrix is designed.
That's fascinating. As far as the footprint, one of the things that we often find is that customers are spatially constrained for deploying systems. I'd imagine, and I have two parts of the question. One is, how does, for an equivalent size project, your footprint compare to the status quo footprint of inverters and all the other components? And then let's run with that 2 megawatt system. What is the footprint of those 400 kilowatt units?
Excellent question. We thought initially that, these massive, massive retailers, I'll use them because that's a great example. They're not going to care. If they've got massive parking lots with thousands of spots, they're not going to care about space constraints. No, the complete opposite. They're not willing to give up a single parking spot, a single small area, more than they have to for their power equipment. And so generally, when we look at everything we're replacing, the 10, 15, sometimes 20 systems, and consolidating that down to DG Matrix, tend to see somewhere between a 10x and 15x, roughly, advantage in terms of that footprint. So the core system is about a meter by a meter, and then you stack those up versus a much larger system that you have to space out over a much, much larger area. So those space constraints really do drive the needle for a lot of these customers.
Yeah, I mean, when you have multiple boxes, you have to have 3 feet around each box for safety reasons. So it's even bigger than the area that the individual boxes occupy.
And the data center world for sure is like trying to get after this really quickly. And there seems to be supply chain constraints everywhere, whether it's transformers, gas turbines, you name it, it's being snapped up. In terms of your production, where do you produce these assets? How quickly can you produce them? And do you foresee similar supply chain constraints, or are you in a position to scale accordingly?
So when we started this business, we took the initial concepts to one of the top global consulting firms. We had some connections, and everybody knows who it is, and it starts with an M, and they're very vaunted in the space. And we said, hey, look, we can build this factory in 9 months, and we can double it and all that. They said, hey, they said it very nicely, but they basically said, you guys are idiots, because if you build a product like this, you're not going to be able to keep up with the demand. And we're like, really? They're like, no, really. And by the way, you need to get it down to 4 or 5 months. And we said, why? And they said, well, because if your order is like 6-9 months, and you see that coming, but you can build a factory quicker and faster, then guess what? You're going to hyperscale, and you need to make a product that's ready to hyperscale. Turns out it's not just the product you have to make. It's the factory you have to. It's a delivery mechanism. It's the factory. It's the way the parts come in. It's the way the parts are assembled. It's the way the parts are shipped, installed, commissioned, and serviced. So we have thought of the whole chain. Today, we're setting up our Raleigh-Durham factory as a duplicate copy of our offshore factory. And in 4 to 5 months, because we signed the lease today, 4 to 5 months, we'll be shipping production units to demonstrate that this is absolutely real. Nice. And so, we designed it that way. I think the constraints for hyperscaling this will come from the supply chain. And we've also done a lot of work in eliminating all parts that have a nasty lead time. Yep. So we're down to the last 1 or 2 parts, 3 parts that you can handle through stocking and pre-arrangement with the main industry suppliers. And they're more than happy to do it, because if they see you're going to take off, they will, for the right commitments, divert the supply to you.
Yeah, I love it. I haven't actually ever heard someone on the podcast talk so highly of a management consultant. Sounds like they did you a good deed there.
They did. They were very nice. There's some incredibly smart people there, and we learned quite a bit from them. And we also got some advice that we ended up pivoting on because the market conditions changed. And we even hired 1 or 2 people from there. And we're looking towards a continued relationship, because they're super nice people, and we found them to be very smart.
That's awesome. Yeah. Can I just clarify on that technical question? Something Dan and I often hear from our customers is, we've installed this solar system, when the power goes out, my power is going to stay on. I'm just fine. And we have to explain to them that no, there has to be a cutoff. When the power goes off, you need to protect the line people, and your solar is not going to generate power. Are you saying that your system will actually allow you with solar only to stay on and ride through an outage as long as the system is producing?
Yeah. So what happens is it's very interesting when the grid goes out, right?
Yep.
The model, the standard that you have to pass is this miraculous scenario where you are supplying what is called a current in electrical engineering, and it happens to resonate with some load that produces a voltage that could be lethal. It's not a very high probability, but that's a very good safety test to go through.
Yep.
And so we understand what happens when the grid goes out because we've been working on this problem for 35 years. And when the grid goes out, it's a dead short because every load is connected. Every load wants every amp, and there's no juice to deliver it. So it's a dead short. So what you have to do is you have to disconnect from the grid very quickly for safety reasons. But also you have to disconnect so you can continue to supply the limited power you have available to the critical loads. So we have a proprietary patent pending architecture in which we can do just that, is we can say, whoops, the grid went out, shut off the grid port, don't give it any more power. Throw out the switch gear and open up the breaker for the grid protection standard. But it's built into our product. We would do that anyway. And then you're able to supply solar, preferably married with battery, so you can do transients and you can do black starts, you can do surges, and you can clear fuses. But yeah, absolutely. We do that, and we've been demonstrating that with our videos on LinkedIn for several months now.
That's amazing. And certainly, like, we're hearing more and more from our customers concerns around power quality issues, especially as some of these big loads come online and as the grid ages. How does the tech support customers with managing power quality, damage to their equipment and their facility?
It certainly does. And the reason it helps is typically if you have very long grid feeders and they have a property that when a surge comes, then all sorts of things happen to the voltage at the end. And there are many scenarios like that. We create a grid for you behind the meter. And so we decouple you from those sags and those surges of the grid. We handle that all on one side. And then we supply clean, uninterrupted power if you bought that option using solar, batteries, gensets, fuel cells, any AC or DC source, and even the grid when it's available. But if it's not, we can disassociate you from it. In addition, we condition all the power and we clean it up before we deliver it to your load. And finally, we have built very high surge capability into our machine. So when a nasty load comes on, it doesn't drag your voltage down and start to interrupt other loads. If you don't have that capability, and I think most solar inverters do not have that capability. They only have 2x the surge because of cost savings. It's a ruthless market. We are building in multiple times the surge capability to do exactly what you're suggesting, Gareth, and not only provide the surges for those high transients, but being able to clear fuses. If there's a short or a fault, you need to be able to clear a fuse before all your branches go dead because there's no power. And we have the ability to do that, and it is an option, but that has to be built in for resiliency for those sensitive customers.
Yeah, nice.
You touched on a couple, but I want to dig in a little bit on what do you believe is one or more of the biggest misconceptions that people have about distributed energy systems, microgrids, on-site energy systems? What have you been experiencing that are some big misconceptions that whether you're having to overcome them or just that you're hearing in the market?
I think a lot of the misconceptions were especially what I would call the underserved segment of commercial and industrial markets that need the microgrid from, let's say, 100 kilowatts to 2-3 megawatts. That's gas stations, supermarkets, box center stores, That's FedEx offices for truck charging. It's commercial buildings, shopping centers. It's a massive market, an aggregate worth hundreds of billions just in the US alone. People have thought that it's very expensive to do microgrids because they're all customized with high engineering costs, high procurement costs, high commissioning costs. And we have busted that myth with this device that's a fraction of that with a fully featured feature, with full featured in it, so that it can solve most, if not all, your problems related to adding distributed generation in a fast, efficient, cost-effective manner.
Yeah.
It took us, believe it or not, 350,000 to 400,000 engineering hours to solve the critical tech problems until we felt, yes, we could deliver it. And then we got the seed money for 20 million to now put pilots out, complete cert, and deploy these, which we're getting ready to do in 1 to 2 weeks.
Yeah, it's amazing. And I think what excites us is, we're here to support those commercial industrial customers to figure out where they should build, what they should build, who they should build with, and being able to toggle on, do I want to go the traditional route or do I want to go the DG matrix route, and being able to see in real time the difference in costs, the difference in schedule. That's super powerful. And I think that really starts moving the needle for everyone, being able to visually see on the fly the impact that you can have. So it's really cool. I think congrats on the funding. Congrats on the new factory. As you think about the next few months, the next few years, what's exciting you most?
Today we have 175 to 180 people, 10 plus PhDs. Wow. Globally. We're hiring in Raleigh-Durham, a record number of PhDs, and in the San Francisco Bay Area. We have been approached by hyperscalers in the data center side, and at least one of them, one of the biggest names in the world today, has told us, you probably have the best architecture for the learning engine cycles. It's a transient that happens multiple times a second. Most products are failing. Most battery chemistries are failing. Only one or two are doing really well. And we agree with them. We think we have the best architecture for mitigating those spikes, providing a power quality, using our generic power router with multiple ports and multiple things. So we're super excited how we can leverage the largest solid-state transformer team in the world that we know of today and be able to really punch through and add value to those hyperscalers. So we're excited about the career opportunities it'll create for extremely smart young people like Michael Wood, right? I think we're looking at a future C-level, a future CEO, a future business owner. And our job is to attract the best people whose brilliance is only exceeded by their humility. And once, like Michael Wood, really, he is that sort of a guy. And once we get people like this, we want to nurture them and develop them. So by the time they go through the school of DG Matrix, they say, man, I learned something that really propelled my career, and I helped them move ahead as well. That's I think, what excites us the most, ability to shape young minds for the next 50, 100 years.
Michael, sounds like you need to be putting a CEO contract in front of Haroon in the next few days. Get that pay bump.
Working on it, Gareth. And I'll add one thing to what Haroon said, and that's deployments. We have a lot of amazing customer interest, some incredible partners and customers that we're working with. And now to be in the next few weeks, being able to deliver units and being able to show it to the world is something that I am unbelievably excited about. So I hope we start seeing many, many more DG Matrix deployments all over the country and all over the world, starting with these first few in a handful of weeks.
Love it.
Love that. Let's switch to our power surge round. I will open with the first question, which might guess what the answer will be for Haroon, but I'm going to ask anyways. Haroon, if you could be any one energy technology, what would it be and why?
Yeah, now, that will have to be an answer that If I wish I could be a flywheel. Why? I don't know. It always seems like you're spinning around and having a lot of fun, and a lot of big loads don't even upset you. You just keep spinning around with that big fat mass you have. So if I could be anything, I'd like to be a flywheel.
I wasn't going to put my money on that, but I love that answer. I think you're the first flywheel we've had. So that's awesome. Michael?
Give me 1 second on this one.
Haroon, you're obviously like super well read. And where do you get your content while Michael thinks about it? Any recommended sources, podcasts, newsletters, articles, journals?
Yeah, I think so. Nowadays I'm a vociferous user of ChatGPT, and I've been honing the different threads to find the best information and to summarize it. So it's interesting, but that's my gateway to gathering info. I like the Wall Street Journal, and I'm looking at more clean tech magazines like that. And then I read these vaunted VCs. Many of them publish the 10 best books I read this year. And so there's some excellent recommendations that end up really changing your ideas about stuff. So I use those lists when I have the time.
All right, Michael, you're on the spot.
I'm going to have to go with the battery. I think just the ethos around flexibility and all the many different fun things you can do with the battery gets me excited. And I feel like that's kind of part of what my role at DG Matrix is a lot of different things and being able to be deployed where needed at any time.
Love that.
Great answer. Michael, I'll start with you. What does this statement look like for you, personally or professionally? In my life, I will have been successful when?
All about scale and impact. My North Star has always been from the start in every decision that I've made, at least in my professional life, of what is going to enable me to be the most successful founder in the future. And so that's kind of the lens through which I look at all career opportunities, and hopefully down the line to, like Haroon talked about earlier, to be able to create opportunities for a massive number of people to go on and do even more awesome things. That's kind of my North Star.
Excellent answer. And I think you've landed in a great spot with a tremendous mentor that's here on the podcast with us. Haroon, I'll pose the same question to you, or have you finish the same sentence. In my life, I will have been successful when
I learn to seize the day and live in the day, because in reality, that's all you have. And so I think once I realized that, I became much happier. That this is the only moment you have, and just live in the moment. Make sure that you respect people. Make sure you respect people even when you don't agree with them. Seize the day. Put your emotional demons to bed. Have a clean mind, and have a lot more gratitude than attitude.
What a wonderful way to end. I think very inspiring, and I would be very nervous if I was one of the equipment incumbents in the market right now. I think what you guys held in sounds incredible. Excited to see it in action and excited to support you to deploy a lot more pieces of gear.
We really appreciate all the excellent questions, the insight behind those questions, the way you asked them, and we look forward to growing a relationship with you.
Likewise. Thank you both for your time. Appreciate it.
Thank you.
Thank you.
Bye.
What stood out to you most?
Yeah, I really like the guys. First of all, I just like the humbleness and the commitment to people and happiness and doing the right thing and having a positive impact. So I really like the human side of it. But from a technology perspective, like I said, it almost sounds too good to be true, but these guys are legit, and I'm super excited to see the system performing in the wild. And for me, the biggest benefit is the ability to go to market quickly, to be able to deploy these systems behind the meter without having to jump through a bunch of interconnection permit hoops, being able to do that with less infrastructure on site, and being able to control an asset in a really streamlined way, it's super powerful. And if it saves money, increases speed, makes installation even more simple, I think it ticks a lot of boxes, and it really helps streamline some of the pain points that we see our developers and customers facing in industry.
For me, having been in this space for quite some time, and you've heard me say it before, but I'm a firm believer that you fall in love with the problem, not the solution.
Yeah.
And I find it fascinating that we and they, the DG Matrix team, have both fallen in love with the same problem, which is this kind of long tail of the commercial industrial market, and how do we get projects deployed faster, with greater economics at scale. And we're just taking two different paths to solve the same problem, and together I think we're gonna see some amazing outcomes, and even individually we're still gonna see some great outcomes. But I think our ability to drive the efficiencies in the development cycle, and their ability to drive the efficiencies in the actual technical cycle, if you will, is just super exciting over the next 5, 10 plus years. So I really appreciate them, and excited to have them on in the not too distant future to talk about some of the projects that we've worked on together.
Yeah, exactly. Amazing, and good for the whole industry, apart from probably their competitors, and I'd be very nervous.
I agree. Beautiful. All right, thanks, guys.
We receive a lot of questions from business leaders around the world wanting to learn more about the energy transition, what is possible, and where to start. So to help you stay informed and up to date on best practices, opportunities, risks, and success stories, we created an industry newsfeed at VECKTA.com/news with all our podcasts, blogs, and newsletter. Check it out and connect with Dan, myself, and the VECKTA team to learn more. Cheers, and have a good one.